Welcome, my dear student. Today we learn about the reverse osmosis. When a solution, that is aqueous solution, is separated from the pure solvent, that is water, by a semi-permeable membrane, the ordinary osmosis occurs naturally. Due to the osmosis, solvent molecules, that is water molecules, move from a solvent, that is a water, to the solution, that is aqueous solution. The pressure that must be applied to the solution to stop the flow of a solvent to a solution is called the osmotic pressure. Therefore, it follows that osmosis can be slowed, stopped, reversed if sufficient pressure is applied to the solution side of the semi-permeable membrane. Pressure equal to osmotic pressure on the solution if the pressure applied on the solution is more than the osmotic pressure. The solvent will start flowing from solution towards pure solvent across the semi-permeable membrane. The solvent molecules will move in the reverse direction from a solution to solvent, that is water. The movement is known as reverse osmosis. Osmosis taking place from a solution to solvent, that is aqueous solution to pure solvent, by application of pressure greater than osmotic pressure on the solution side is known as reverse osmosis. The applied pressure forces the water molecules from the solution into water across a semi-permeable membrane, leaving behind all the dissolved salt. The amount of the pressure required depends on the salt concentration in the solution. The more concentrated the solution, more pressure is required to overcome the osmotic pressure. A general reverse osmosis system, that is RO system, the solution from which a pure solvent is to be obtained is called feed water. The desalinated, demineralized, deionized water obtained is called a permeate. The water which doesn't pass through the reverse osmosis membrane and contains the contaminants or concentrated salt forms the rejected stream. The feed water with a high pressure pump, then the salt solution through semi-permeable membrane gives the pure water and the permeate water, and other that can be contaminated water that can be ejected, that is the reject stream. The feed water is pumped under a pressure greater than the osmotic pressure of the solution into the vessel fitted with a suitable reverse osmosis membrane. Under the influence of high pressure, pure water passes through the RO membrane as consider. The rate of flow of water is equal to delta P minus delta pi, kWA divided by delta. Delta P is equal to hydraulic pressure differential across the membrane. Delta pi is osmotic pressure differential across the membrane. Kw is a membrane permeability coefficient for water. E is a membrane area, and delta is a membrane thickness. RO membrane, reverse osmosis membrane, the choice of RO membrane depends on the nature of feed water. Two types of materials make up the bulk of a commercial RO membrane. They are hollow fibers of nylon or cellulose acetate, and second, that is aromatic polyamide, that is aramide. The cellulose acetate membrane, the RO membrane, first obtained in the 1950s from cellulose acetate, were dense and they permitted very low flow rate. But nowadays, cellulose membrane as thin as 0.1 to 1 micrometer called skin of a membrane have been prepared. These skins are supported by a porous cellulose structure. Such membrane permits high water flow rate. These membranes are susceptible to degradation from a biological attack. Therefore, feed water is to be properly chlorinated before it is fed into the RO system. Moreover, cellulose acetate hydrolyzes back to cellulose under the acidic or the more basic conditions. To prevent the hydrolysis, the pH of the system is maintained in the range of 4.5 to 7.5. Second, that is the aromatic polyamide, aramide. RO membranes are also prepared from aromatic polyamide. In the pH range 4 to 11, these membranes resist hydrolysis and hydrolysis and the immuno to biological attack. These membranes are found to degrade in presence of free chlorine. Therefore, the feed water must be dechlorinated before subjecting to reverse osmosis. Reverse osmosis membrane is capable of removing 99% of dissolved salt, suspended solid, colloids, pathogens, organics, pyrogens, algae, plankton, poliovirus, macromolecules, macromoles, etc. The semi-permeable membranes prepared so far are not completely semi-permeable. They allow passage of salts to a varying degree. In case of that, the aromatic polyamide. The applications of reverse osmosis, desalination of seawater. RO can be used for desalination of the seawater to obtain fresh drinking water. This is done with the help of hollow fibers of nylon or cellulose acetate, whose walls act as a semi-permeable membrane. Water is introduced under pressure around the hollow fiber. Fresh water is obtained from inside the fiber. Each hollow fiber until contain more than 3 million fibers bundled together. Each fiber is of about the diameter of human hair. RO technique is used in Gulf countries for getting drinking water from seawater. The osmotic pressure of seawater is 4 to 5.5 megapascal due to the presence of 35,000 to 42,000 milligram per liter of the dissolved salts. For RO, the applied pressure should be 1.4 megapascal more than the osmotic pressure. Hence, for the purification of seawater by RO technique, the pressure applied should be in the range of 5.4 to 6.9 megapascal. Means the 5.4 minus the 4 means the 1.4 megapascal is essential. The essential pressure. The water obtained after reverse osmosis contains 500 to 725 milligram per liter of dissolved salts. Membranes that have carbon nanotubes are as pores could be used in a desalination. Nanotube membrane offer possibility of cheaper desalination. Small RO plants are set up for seawater purification to supply water to offshore drilling rigs. Rainwater collected from sewers is purified using RO technique to obtain a pure water. In industries, RO is used to remove minerals from the water, which is used in boilers of a power plant. Reverse osmosis along with ion exchangers is now extensively used by electronic industry to produce ultra pure water for manufacturing electronic components. It is also used in a clean effluent and a blackish water. In a food industry, RO is used to concentrate fruit juices. RO is also used to purify liquids in which water is an impurity. The household water purifier includes a step of RO for improving water for a drinking purpose. Reverse osmosis or reverse osmosis system are becoming exceedingly popular in the home market. Listed below are some contaminants which a RO system can remove or reduce from home tap water. It removes arsenic, chlorine, fluoride, odors, bad taste, heavy metals, nitrates, debris, sediment, and iron. Second, that it reduces the amount of hydrogen sulfide, benzene, and other volatile substances. Thank you.